Hello and welcome to double angle identities. These are the last new identities in the chapter. So I'm going to start by looking at sine of 2 theta and seeing what we can do about that. Well, one thing I can do is this. I can break up the 2 thetas and make it theta plus theta. And if I use my identity for the sum of 2 angles, it's going to look like this. I'm going to get sine theta times cos theta plus cos theta times sine theta. In other words, I've got 2 of these sine theta times cos thetas. And guess what? That is the double angle identity. It says sine of double an angle equals 2 times sine theta times cos theta. And that's the first of our identities. Now, let's have a look at cosine of a double angle. Now, how do I figure this one out? I do the same trick exactly. Okay, so we're going to change the 2 theta into theta plus theta. So I get cos of the first times cos of the second minus sine of the first times sine of the second. Now look at this identity. It's kind of cool. Cos squared theta minus sine squared theta. All right, so that's a double angle for cosine. Now what we tend to do, we do a little bit of rearrangements based on cos squared minus sine squared. Remember, we still have this identity here. Good old sine squared plus cos squared equals 1. And so we could rearrange this, and we can solve for sine squared, and we can solve for cos squared. And I'll show you what I'm talking about. So let's go back to a clear screen. We're talking cosine of a double angle. And we know it equals this, okay, because we just did that. Now, suppose I picked one of these. I don't really care which one. Let's say I'm going to take out the sine squared, and in its place I am going to substitute something that's equal to sine squared. Now, equal to sine squared would mean that I would have subtracted the cosine to the other side. So I would have 1 minus cos squared. And I'm talking about using this identity here. This is where I'm getting it from. Okay, sine squared plus cos squared equals 1. If you subtract cos squared to the other side, that's the same as sine squared. So I'm putting 1 minus cos squared in for the sine squared up here. Little substitution. Well, if I clean this up, I have a cos squared plus another cos squared. So there's 2 cos squareds. And then I have a minus 1. So guess what? This is a new version of the cosine identity. Then there is one more for cosine, and you can probably guess where it's coming from. So better write it all out. Okay, we know we're starting with cos squared minus sine squared. And then what I do is I'm going to replace cos squared. Well, cos squared would be the same thing as if I moved the sine squared over. I would have 1 minus sine squared minus the other sine squared. Okay, so here's my substitution right here. And if I clean up that mess a little bit, it looks like I have a 1 minus 2 sine squareds. And that would be absolutely correct. So we have, in fact, for cos 2 theta, there are 3 different versions of the identity. And the one that you decide to use in a proof tends to be the one that, it's the most practical. Usually it revolves around getting rid of ones. And you'll see that when I do an example later on. Okay, I got one other identity to show you, and then that's it. And of course, this has to do with tangent. Tangent of 2 thetas. What would that look like? Well, we're going to use the same trick, yes, one more time. Theta plus theta. So what does that look like? Well, you get a tan of the first plus a tan of the second, all divided by 1 minus tan of the first times tan of the second. So what does that finally look like? Well, you have 2 of these tan thetas on the top, and on the bottom you have 1 minus tan squared. Okay? And so that's the final identity. Right there, folks. Right there. Well, that's where I'm going to stop. It's probably enough note-taking, and you probably need a break. So we're going to stop there, come back with some proofs.